Good evening, Chem students. Tonight we're going to talk about ideal gas law, the ideal gas law. Basically what the ideal gas law is it's one formula that combines any unknown. Pressure, volume, moles, and temperature. All of these are combined into one handy-dandy formula. We also have a constant, but we're going to talk about that in just a second. Our formula is very simple. It's PV equals nRT. This is another formula that we'll need to remember, so you should please star that. So let's talk about each individual unit. So first off, we have P. It still stands for pressure. Your pressure this time has to be in ATM or it has to be in kPa. Alright, pressure has to be in ATM or kPa. V, our volume, it needs to be in liters. It has to be in liters. N is moles. We haven't seen that one and we haven't used it for a while. So N is our moles, and obviously it has to be in moles. And so sometimes you might have to go from grams to moles. And remember, to get to grams, from grams to moles, is we're going to have to divide by the molar mass. Alright, R is our gas constant. Alright, and with the word constant in there, you should know that it is constant. But we have two different options. We have 0.0821, and that's if your pressure is in ATMs. We also have 8.314, and that's if your pressure is in kPa. So we have a choice depending on what our pressure is in. So let's highlight those appropriately. If you have ATMs, you're going to use 0.0821. If you have kPa as pressures, you're going to use 8.314. All right, rolling on. Let's finish this. T is temperature, and it still has to be in Kelvin. All right, so you'll probably have to add 273 to the degrees Celsius. So let's take a look and see if we can't work one of these practice problems out. So this first example says a sample of hydrogen gas, H2, has a volume of 8.56 liters at a temperature of 0 degrees C and a pressure of 1 atm. We're supposed to calculate the moles of H2, then calculate the number of grams. So if we look, our formula that we're going to use is PV equals nRT. So that's our formula that we need to use. And if we just go through and find what we have P. What's our pressure? Well, our pressure is 1.5 atm. So we'll plug that in there. V is our volume. It is 8.56 liters. Notice it's already in liters, so we're set. We have N, and if you look, it says calculate the number of moles, so we're looking for moles. R is our gas constant. This is where we have to look and see which pressure do we have. We have ATM, so we're going to use 0.0821 as our constant. And then we have T, which is our temperature, and we have a 0 degrees Celsius, and we're obviously going to have to take that to Kelvin. So let's go ahead and do that now. So to get to Kelvin, we're going to add 273.15. And so obviously our Kelvin temp is 273.15. And if we go ahead and solve this for N, we're going to divide each side by RT, divide by RT. So N is going to be PV over RT. And so now we're ready to plug it in. We've got 1.5 atm times 8.56 divided by 0.0821, and then we're going to multiply by our temperature, 273.15. This will give us our number of moles of hydrogen gas. So let's just plug those babies in. 1.5 times 8.56 equals, and we're going to divide by 0.0821. And we're going to divide by 273.15. And that will be 0.57573 moles of H2. All right, so let's take a second and soak that in and make sure we're still good on that. That's our first question. Calculate the moles of H2. Our next step says to convert from moles to grams. So if we have 0.573 moles of H2, we can now take that to grams by saying 1 mole of H2, and we can do the molar mass on top, which is 2.016 grams of H2, and we found that by taking kind of a little slide. Each H is 1.00794, so we multiplied that by 2, giving us 2.016. All right? So all we have to do is take 0.573 and multiply that by 2.0156. Or 2.016. And we should get 1.15 grams of H2. And there you have it. Pretty simple. All right, awesome. Let's move on to the next one. The next one says a weather balloon contains 1.10 times 10 to the 5th moles of helium, has a volume of 2.70 times 10 to the 6th liters of gas at 1 atm pressure. Calculate the temperature in Kelvin. Then we're supposed to take it to degrees C. So if we look, we're going to start. We've still got PV equals nRT. We've got P, look at that, 1.00 atm. V is our volume. Our volume is 2.70 times 10 to the 6th liters, so we're good there. N is our moles, and we've got 1.10 times 10 to the 5th moles. We've got R, our gas constant, question mark. T, not question mark, man, we know what that is. It is 0.0821 because our pressure is in ATM. T is our question mark. I got a little ahead of myself. So we're going to go ahead and solve for T. So I'm going to divide each side by NR to isolate T, and T will be equal to P times V over NR. So now we're ready to plug these babies in. We've got a pressure of 1. We've got a volume of 2.70 times 10 to the 6th. We're going to divide that by our moles, 1.10 times 10 to the 5th, and then times our gas constant, 0.0821. This will be our temperature in Kelvin when we multiply it out. So 1 times 2.70 times 10 to the 6th divided by 1.10 times 10 to the 5th and divide by 0.0821. And we should get 298.97, and that's our temperature in Kelvin. 298.97. If we wanted to do sig figs, we could. It would be 299 Kelvin. But the next question says we're supposed to also calculate it in degrees C. So to get from Kelvin to degrees C, we know here's our formula. Kelvin equals degrees C plus 273.15. So if we put 299 over here equals degrees C plus 273.15, we're going to take 299 minus 273.15. This will give us our answer. Our degrees Celsius is 25.85 degrees Celsius. There we go. See you next time.